Good evening. Selena is here with me for a geography lesson to share with you, and she brought along our little cat, Kelly. And so I hope that you are as excited as I am to have this new lesson. We have done a lot of work of air lessons, all the way from the first one when we talked about the two kinds of heat, and we had two kinds of heat. One when we had the candle and we felt the heat from the candle, and that's called direct heat. Heat that comes from something that's on fire is called direct heat. And then we heated up the spoon, and then we felt on our hands the warm spoon, and the spoon had absorbed the heat from the fire, but the spoon wasn't on fire itself, and we call that radiant heat. So we learned about the two types of heat. And then we talked about how hot air rises, and we talked about the layers of the atmosphere, and we showed everyone's favorite chart, dead bread in a bed. And we looked at how when there's few layers of atmosphere, they're not trapping in the radiant heat from the earth, and so Fred got cold. And then we showed the chart live Fred in a bed where he had lots of layers of his atmosphere blankets, and so it trapped that heat in and kept him warm. Okay, and then we did things like we had the bottle with the funnel on top, and we tried to pour the water in, and we learned that air takes up space. And then we had the lesson with the chimney and the incense, and we had the candle inside there, so the warm air in the chimney was going up. And then when we held the incense out, it was sucking the smoke from the incense into the chimney. So I want to talk more about that process of when the warm air inside the chimney was rising, what that looks like on Earth. Okay, so here I'm going to share a new chart with you. Let me switch modes here. Okay, here I have a chart, and you can see that this is the Earth, and we see the Earth in 4 different places, but we're going to start with this one right here. And the Earth, instead of being depicted like we see it on the globe with the equator around the middle, this one actually has the equator right here. So you can see the sun's rays are coming straight down right here. And these are, this little person is wearing a parka representing the north, and this penguin is representing the south, because we know penguins live in the south. So this person right here is representing the North Pole, and the penguin is representing the South Pole, and the equator is right in the middle. So through a lot of our sun and earth lessons, we talked about how the sun's rays are perpendicular to the equator most of the year, or pretty close. And so the rays are striking the equator and warming up that land. Just like our chimney experiment, what happens to the air? Can you put her down, please? Yeah. She doesn't want to be at the lesson. Okay, so as the sun's rays are perpendicular to the equator, what's happening to the air?
It's rising.
It's getting warm, and warm air rises. Just like when we talked about the properties of properties during our first great story, and we talked about how hot things rise and cool things sink. Okay, so here we have this picture showing that the warm air that's at the equator is heating up and it's rising. You can see those up arrows, it's rising. And then think about our chimney experiment. The hot air inside the chimney was rising, and then the incense air was the cool air on the outside, and the cool air was rushing into the chimney, pushing in and filling in that empty space. So here we have the hot air rising, the red arrow right there, and we have this cool air coming in to fill the space. So we've got hot air rising, and now we have cool air coming in. Okay, and something happens once that cool air comes in. It's at the equator where the rays are perpendicular. Now it's sitting at the equator. What's going to happen?
It's going to heat up.
It's going to heat up. So now the hot air has risen, gotten out of the way. The cool air has rushed in to take its place. It's warmed up. Now it has to rise. So that's what we're seeing here. The warm air rises, and it's pushed and pushed. As that new air rushes in and pushes, it's pushing that cold air, or that warm air that goes up into the atmosphere, it's pushing it towards the poles. And you can see now our little guy in the parka is leaning into that air that's coming in. So the warm air rises, the cool air rushes in, takes its place and warms, and it pushes that air that's risen to the poles. It's happening this South Pole too. The penguin didn't look any different, he just looks the same. The cold air, or the warm air rises, it pushes to the side, up towards the poles, and then it comes back. And so it's rising, pushing out and pushing back in. So we can see that here, this is the whole cycle right here. You can see how the hot air is rising. It's pushing out towards the poles and swooping back in and rising again. You can't see my hands. I'm going off the screen. The hot air rises, the cool air rushes in to take its place. It keeps pushing and it keeps pushing, and we get a cycle of the air in the atmosphere. Now I want to show you one more chart while we're here. This chart brings the Earth back into the shape like we're used to seeing it, like on the globe. The equator goes across here horizontally. The North Pole is at the top and the South Pole is at the bottom. So what we can see happening here is the air here at the equator is getting hot and it's rising. I'm going to go to the South Pole. The hot air is rising and it's coming out, and this cool air is pushing in. And as that cool air pushes in, it gets warm and it comes out. And so this warm air gets pushed towards the South Pole, and the cold air gets pushed or gets sucked in and gets warmed, and it comes up as well. The same thing's happening in the northern hemisphere. The warm air at the equator is pushing up. The cold air comes in and pushes it further, and the cold air keeps pushing and it keeps pushing until the warm air gets up to the poles. And one thing about it is the further it gets from the equator, it starts to cool and cool and cool until it's cold air again. So that's how we get that down cycle. It's pushed up, it's warm, 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 it's warm in the atmosphere, it's cooling, 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 and it's cold. And it's warming, 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 warm, cold, 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 cold. And so that's what we're seeing here, is that there's the cycle of the warm air is the warm air rises, the cool air comes in and takes that place. So what I wanted to talk to you about is that where the air is rising, the weight of the air is less because it's lightning or lightning is a really strange word. It's getting less dense, maybe. It's getting lighter. The air is rising. So we know hot things rise. The particles are loose as they're going up. So this is called low pressure. The air weighs less as it's rising because the heat is bringing it up. So the air is not as heavy. It's called low pressure. Where we get the air coming back down, where it's cold, where the cold air is sinking, it's normal air, but it's heavy air. We call that high pressure. So it's low pressure when it's sucking up, and it's high pressure when it's pushing down. Okay, there's two different kinds or types or streams of wind. There's atmospheric wind and there is surface winds. On the chart, the atmospheric winds are shown in red because those are those are the warm air winds, and the surface winds are shown in blue because those are the ones that take the place or fill in. So the atmospheric winds are the winds where the warm air is rising into the atmosphere and flowing through the atmosphere, atmospheric winds. And here when we have high pressure and the cold air is sinking, they're coming along the surface, and those are called surface winds. And so we have two types of wind created on Earth: atmospheric winds from low pressure, from warm air rising, and we have surface winds from high pressure that come in when the cold air takes its place. So I hope that you have enjoyed these two new charts with talking about how the winds are created and how they affect the planet. And I can't wait to see what creativity you have to share with me about this. I know that some of you have probably already thought of a way to model this or to show this. So I can't wait to see what you come up with. And so I hope that you've enjoyed this new work of wind, that I know that when we do the experiments in class, you love that. And so I'm hoping that the charts bring just as much joy. I hope you have a great night. Bye.